Okay, so this is my Skill 2 video, and the goal is to find the radius of the circle, where you're given p, a number which I chose, and theta. And so for theta, I decided to choose 60 degrees, and for p, I chose 5 units. And p in this problem, although it may look like it's just this length, that's not what it is. P represents an area of the area of this sector over the arc length of this little piece here. So that's what P is. It's a ratio, my bad. So basically I went about doing this by setting up a few proportions. So you can see this in my mechanical work. I started off with a proportion. Of course, my P is 5. Again, just got to remind myself. P is 5, and of course, if it's just 5, that means your ratio is 5 to 1, because 5 over 1 is equal to 5. And if 5 over 1 is your ratio of area to arc length, I can compare this to the total area over the total circumference. And I did this through a proportion, as you can see. And in this proportion, I solved for r, where I had pi r squared, the formula for area, over 2 pi r, the formula for the circumference of a circle, being equal to 5 over 1. So immediately you can cancel out the pi's, and r squared over r is equal to r. So you end up getting r over 2 being equal to 5. And when you solve for r, you get 10, your radius of 10. Now I wanted to go through and check this in more depth, so I set up another set of proportions in which I utilized theta, because I realized that, of course, you're given theta. I wanted to be able to use that in my problem and make sure that what I'm doing is correct. So what I had was x over 100 pi, which we are assuming that the radius is 10. So x over 100 pi is equal to 60 over 360. So theta is equal to 60, the whole entire circle is going to be 360 degrees, and x is going to be your area of this sector. And so then we solve for x, we get around 52.36, and then we do the same thing with circumference, except we have the whole circumference, which would be 20 pi if we're assuming that the radius is 10. So y over 20 pi is again equal to 60 over 360. And so we get that the circumference of this, or the arc length of this small piece, would be about 10.472. Now what we do is create another ratio like we had with P, with the calculated area over the calculated arc length, sector area over arc length, in which we get about 5. It's about 5.00 something, which we can assume is 5, which shows us that our radius is in fact 10 units. And that's basically how you would find the radius of the circle.